Hello and welcome in mechanical system design subject. Today we will solve the problems on unit number 2, that is a statistical consideration in design. So here it is a problem statement. The weightage of this problem is 6 marks. So the statement of the problem is as follows. Tensile strength of the population of 1000 connecting rods are normally distributed with the mean of 500 megapascal and a standard deviation of 50 megapascal. Find the number of connecting rods having strength less than 450 megapascal. So this is the problem statement. Our aim is to find out the number of connecting rods having strength less than 450 megapascal. So here 1000 connecting rods are produced. Out of that, the mean is 500 megapascal and a standard deviation is 50 megapascal. So our aim is to find out the connecting rods or the number of connecting rods having strength less than 450 megapascal. So in solution, given data, that is a n number of connecting rods are equal to 1000. Then mean is given as a 500 megapascal. So mu is equal to 500 megapascal. Then sigma cap, that is the standard deviation, is a 50 megapascal. Now first we are going to calculate, or we are going to find out the standard variable. So x is the random variable and f of x is the frequency of that random variable. Mu is the mean and x1 is the observation. Then conversion of normal variable into the standard normal variable will be the plus z to minus z. Then on y-axis there will be the f of z. So the x variable is replaced by z variable in case of a standard normal distribution curve. Then at x1 is equal to 450 megapascal, z1 is equal to the x1 minus mu upon sigma cap. So that will be equal to 450 minus 500 divided by 50. So that is equal to the minus 1. So here z1 value is a minus 1. So here on this normal distribution curve, we mount z1 is equal to minus 1. So the area below the curve from z is equal to minus 1 to z is equal to minus infinity, that will be the number of component with the strength less than 450 megapascal. Therefore, the number of connecting rods having strength less than 450 . We are going to calculate the area. Let A is equal to the area below the standard normal distribution curve from z is equal to minus 1 to z is equal to 0, which is equal to the area below the standard normal distribution curve from z is equal to 0 to z is equal to plus 1. Therefore, from standard table, we will get the area below the standard normal distribution curve equal to 0.3413. Therefore, percentage of connecting rods having strength less than 450 megapascal is equal to 0.5 minus A into 100. Therefore, 0.5 minus 0.3413 into 100. So 15.87 are the percentage of connecting rods having strength less than 450 megapascal. Therefore, the number of connecting rods having strength less than 450 megapascal is equal to 15.87 upon 100 into 1000. So 1000 are the total number of components and 15.87 by 100 is the percentage of the connecting rods having strength less than 450. Therefore, 158.7, that is a 159 are the number of connecting rods having strength less than 450 mm. So in this way, we can calculate the number of connecting rods having strength less than 450 mm from the given 1000 number of a sample. Now we will solve another problem. A batch of 100 deep groove ball bearing having a normally distributed failure time with a mean of 10,000 hours, a standard deviation of 750 hours. So how many bearings are likely to be failed within first 11,000 hours? Batch size is 100 deep groove ball bearings is given. The area below the standard normal distribution curve from Z is equal to 0 to Z are as follows. So these are the area values are given for Z is equal to 1, 1.1, 1.2, 1.32, 1.6. So solution in given the mu, that is a mean, is given as a 10,000 hours. Then a standard deviation is given as a 750 hours. X1 first observation, X1 is likely to be failed, that is a 11,000 hours. Therefore, this is a standard variable curve. So X will be the standard variable. X1 will be the first observation. Mu is the mean, and f of X is the frequency of observation. Then at X1 is equal to 11,000 hours. Z1 is equal to X1 minus mu upon sigma cap. Therefore, by putting the value of X1, mu, and standard deviation, that is the mean and standard deviation, we'll get Z1 is equal to plus 1.333. So here we draw the standard normal distribution curve from Z is equal to 0 to Z is equal to plus 1.333. So the bearing likely to be fail within first 8,800 hours. So the number of bearings likely to be failed, that is our aim is to calculate. So as shown in the figure 2.8.1b, the shaded area below the curve represent the bearings likely to be failed within first 8,008 hours. So this is the shaded area for which the bearings are likely to be failed within first 8,800 hours. So let A1 is the area below the standard curve or standard normal distribution curve from Z is equal to minus infinity to Z is equal to 0, and A2 is the area below the standard normal distribution curve from Z is equal to 0 to Z is equal to plus 1.33. Means the area below the standard normal distribution curve from Z is equal to minus infinity to Z is equal to 0, that area will be equal to A1, and area from Z is equal to 0 to Z is equal to 1.33. So this area will be equal to A2. So from table given by linear interpolation, area A2 is calculated by using this standard formula. So we will get the area below the standard normal distribution curve from Z is equal to 0 to Z is equal to plus 1.33, 0.485, and A1 is equal to the 0.5, as the total area below the standard normal distribution curve is 1. Therefore, the half area below the standard normal distribution curve will be equal to 0.5. So A1 will be equal to 0.5. Therefore, the number of bearings likely to be failed within first 11,000 hours, so that will be equal to the by using the formula A1 plus A2 into 100. Therefore, 0.5 plus, so 0.5 is the area A1 and 0.4058 is the area A2 into 100. You will get the 90.85 as the number of bearings likely to be failed within first 11,000 hours. So 90.85 or 91s are the number of bearings likely to be failed. Therefore, the number of bearings likely to be failed within first 11,000 hours will be equal to 92. So here there will be a mistake in book. So here it should be the 11,000 hours and not 8,800 hours. So in problem statement, if it is given as 11,000 hours, so that will be the 11,000 hours. So thank you for the watching the problems on statistical consideration in the design.